Kenneth?
Nope.
Going to buy some breakfast.
Yeah, but knowing Kenneth, it's possible that he's reviewing some PRs on the way over. Or sending some pull requests.
Was I don't know. Let's just. Have more ridiculous. I guess. Okay, Kenneth has asked me to get started. I guess everybody else is smart enough to avoid my talk. So you're really stuck with me for the next half hour or so. I guess I wanted to say a couple things that I forgot to mention yesterday about LMOD. One of the features that we really like is what I call the NAG message. So you can have a file that has key value pairs in it, and anytime anybody loads that module, they'll get a message. And I've got a feature request to have that happen when you do other things like show and help. But anyway, so that can be really useful if you want to deprecate something. You don't have to send targeted emails. It affects the it gets the people who actually load it. They get the message, and that can be useful. The other thing is that I know that I am and the guy from Shell, I think, was interested in tracking module usage. So LMOD has this hook that will allow you to do something every time there's a load. And so you can send a message to syslog or whatever you want to do and then process that. And then what I'm doing is taking that data and driving it to a database. But you could just as easily use Splunk or the Elasticsearch tools to find out what people are using, what modules and stuff. And we found that to be useful, but because we put our stuff on the local disk, we can't store everything, so we have to take stuff off. And those are the things I can think of at the moment. Yeah. Any questions? Okay. So let me start talking about XALT. First of all, Mark Fahey is the co-PI on this project, and I guess Ruben is now too, and then my student Sandra Sweat have been working on this. It's a National Science Foundation funded project with myself and Mark as the PIs. What it does is take a census of what programs and libraries are run. And it's currently being run at TACC, NICS, CAUS, and now NCSA. They're all, well, several of them are supercomputer centers in the US. Obviously CAUS is not, trying to spread the word about it. And it integrates with TACC, which is a tool that a colleague I work on, which allows you to do performance model measuring. The goals of this thing are to be extremely lightweight. I want to be able to produce provenance data. What libraries get used and what applications get used that we built. As a supercomputer center who's generating stuff, we'd like to know what people are using and what they're not. If they're not using it, we don't have to support it, we don't have to build it. Of course, EasyBuild makes building a lot easier. We do it in a slightly different way. It's a little bit more work for us. So we can also direct people away from this library to that library if we know what they're using. And we can collect data for analysis. And I'll talk about some of the analysis things we've done with it. So I got to do something to find out what you're doing. So the way we do it is we hijack the linker. So the linker is we have a script called LD, which intercepts the user's line, and this shell script, which then calls Python scripts to do some stuff and generate key value pairs. And we capture the output, the trace map output from LD, so we know what you've linked in. And then we collect that result into a JSON file. We used to have to also capture the job launcher. MPI run, AP run, we have a thing called IB run, they have a thing here called my MPI run. And we had to have a shell script wrapper, which also uses Python scripts to find the command line. And that is one royal pain in the ass because everybody does it differently, and there are other interesting problems with that. Then we collect the executable info, the shared libraries and environment, and then also transmit that data into a JSON file and save it away, which I'll get to later. Fortunately, we don't have to do this anymore because it's been a real pain. So we've got JSON files or JSON data. We can do one of three things with it. We can write it to a file in the user's account, which is certainly the best way to start testing it, or send it straight through syslog or any other transmit tool. Well, right now we support syslog, but this is easily could support RabbitMQ or whatever you like. Or you can actually have it go directly to the database. We currently use the file method, although I'm going to move away from that. Syslog is what my partner does at NICS, Actually, they use syslog for some things, and other machines they go directly to DB. This project started out as sort of joint work between an old tool of mine and an old tool of his. And his tool, Alt-D, was capturing LD, and it wrote directly to the database. And so they did that for years. So it's possible to do it that way, or any other. So we're using all three mechanisms. So in my mind, this project really started from LMOD and Spider. Because one of the things that I'm interested in is knowing not what files get used, but really what modules get used. And so I use, and we've all heard lots of things about Module Spider, but the main thing it does is it walks the entire module tree. So you know all the modules that are, well, all the system modules that are on the system. So a user who has their own private module systems will never see in Spider, at least from the system point of view. But what I can do is I build what I call a reverse map. So Spider says, here's the module, and here's all the here's all the paths that are associated with it. So I can take that map and reverse it and get directories that are then associated with the module. And I can use that to map the program and libraries to modules, if such a mapping exists. So for example, this long path, which represents one of the HDF5 libraries, can be mapped to a particular, our parallel HDF5 that's implemented by Intel and in Bappage 2. Now this is less useful than it needs to be, but it still can be an issue. And it's one of the things, since I know the author of LMOD, I've added a feature to LMOD to allow me to do what I call priority path, which says some paths are more equal than others. And so when you do a prepend path, normally you would say prepend path and then the path string. But you can add this extra thing called a priority, which says I have a higher priority. Normal paths have a priority of 1, and this has a priority of 100, so it gets shifted all the way to the left. So it's going to be early in the path. So every time the path is reconstructed through the module system, it pumps this one first. So that's kind of useful for this. There's also, you can have negative if you want to have a path that's always going to be at the end. You know, sort of a catch basin for things. So I was going to title this talk "Big Data Sucks" because I'm producing a lot of data. We produce, right now, collecting just MPI jobs, we do about 7,000 jobs a day. That's 7,000 invocations of submitting a job or get run every day, which turns out because of once you're in the queue, it's more efficient to do multiple executions rather than one. So, and it says I'm collecting how many times things get run. We're getting 10 to 20,000 jobs, 10 to 20,000 XALT records a day, and that adds up. And then on the other hand, and the other thing was I'm tracking environment. I'm tracking environment the environment module. So I'm tracking all of them at the moment. I'm going to change that. So I've discovered that 2 billion is not a very big number. That we have about 8 million jobs a year with an average of about 250 environment variables per job, and you multiply those numbers together, and all of a sudden you get to 2 billion. So, and that's how I told, I'm using a MySQL database, and I told it the counter would be an int. And what did I know? That's a signed int, so that only allows for 2 billion records. So right now I'm not storing any environment variables. I'm going to have to redo the database, but redesign the database. But I'm getting, the thing that I never thought would be so important turned out to be huge. So that represents, and that's, 200 gigabytes of data. In fact, this sits on a VM and I've swallowed it. I've now got the disk drive 100% full, and I'm in the process of trying to fix it from here. So I'm planning on implementing the database. So environment variables are important. Yeah.
So what's the plan with all that then? I mean, do you really need to keep it all, or can't you just put down stuff that you're actually interested in?
My next slide.
Okay.
So I'm interested in environment variables in two ways. One, environment variables, especially the ones that talk to MPI, can be important, and I want to be able to do tests against those. But most of them, I don't care. We all set PS1, well, we may not export it, but I don't care what PS1 is. It's not going to affect the job. So, but I'd like to be able to report to you that the, 6 months from now, I can tell you exactly how your program got run. And so that I'd like to be able to produce the environment variable list. But I can do what I'm going to do, and what I'm saying here is, they're important, but they're mainly for reproducing results, providing providence. So, but not many I need against SQL tests. So what I'm going to do is I'm going to create a JSON blob, a string essentially, and compress it, and that'll save me a lot. So I'll be able to recover your environment, but not have to store it in this complicated way. And then I'm going to filter environment variables, have an accept test and a reject test. So if you pass the accept test, then I don't do the reject test, but essentially cut down the number of about 250 to about 10 to 20, or 20 to 30. And hopefully that's going to help. And I'm also going to change the indices from int to unsigned big int, so I don't run into this problem. But some of you may be aware that we have this big data machine called Wrangler, which has a lot of SSDs on it. I may have to move XALT to it. And the people who run Wrangler are interested in having XALT on their system as well, and they've got completely different needs in terms of what they want to track, because they're not a big MPI machine, they're a big data motion machine. So things that I would never track on Stampede on our HPC system, they're going to want to track. We'll talk more about that later. So I discovered that American English doesn't quite cut it. That all you people have different extra characters. This is blasphemy. Stop doing it. Sorry. Anyway, just a typical American. What do I know? But the problem is that even in Texas, people will use, Unix file systems support UTF-8 characters. And people are naming directories and executables with all kinds of strange characters. Ends with these little tildes on top. Anyway, and it broke XALT really hard. And so it took me a long time to figure out how to, I think it was, the database would support UTF-8, and Python will support UTF-8, but it took me a long time to find a way for them to safely communicate. I finally have, and it was the right thing to do, but UTF-8 and Python, at least Python 2, is just painful. So I changed this, use this cursor execute function, and it works much better. And this also prevents SQL injection, so I won't get killed if somebody names their program Johnny Drop Tables with some semicolons in there. And it supports UTF-8 characters. The other problem I have is, and I know that EasyBuild has a somewhat similar problem, although not quite the same way. I'm running Python in user space, and users are evil. I'd be a lot better off if I didn't have users. So I think there are more ways I can get in trouble, but at least these are the 4 that I know about. And you guys can tell me which ones I've missed. But I know I can get in trouble with somebody screwing up on LD library path. I've run across a case where somebody was building something which Python was able to use, and it changed the way, it just messed Python up. Path and Python home. So I'm now running my scripts with, I'm setting LD library path to the one that was when you configured XALT. I'm setting the path to nothing, which means I have to supply absolute paths to everything inside my stuff. And then I'm using the absolute path to, that's what this means to me is, configure is replacing that with the absolute path to Python that you ran with. The minus capital E, which says ignore whatever the user set Python path into Python home to, and then my Python script. And that at least protects me as far as I know, but Kenneth, there's something else I'm supposed to do here? I mean, I'm supposed to have more flags or something? You were saying something about this, but anyway.
And EasyBuild, we unset everything that starts with Python.
You said everything that's what?
We unset everything that starts with Python. So not only Python path, Python home, there may be other stuff. You just make sure everything that starts with Python, just, yeah, whatever.
Well, maybe I have a few more things to add, but one of the things is that some people with multiple, with shared home file systems with different operating systems are going to have to install XALT uniquely per OS, because one of the problems is that base name, for example, sometimes is in bin base name, sometimes it's in user bin base name. So, especially you going like, CentOS is pretty good, CentOS 6 to CentOS 7 is fine, but you go CentOS to SUSE or SLES or something, they're different. So, the thing we use a lot, as I said, since we have local disks and we do most of our installs on local disks, we want to know who's going to be affected because we're going to remove stuff. I assume that the biologists aren't happy, but stuff is going to move. I know that many of you support biologists and they'd like to be able to run the same stuff forever. Can't happen on our systems. So we want to know who's going to be affected and help migrate them. And we had an interesting problem with the large memory queue. So we have, like many sites, we have a small number of 1 terabyte nodes. So people who need big memory and don't necessarily need to scale much can use them, but it's 16 nodes or something like that. So it's easy for it to get oversubscribed. And I discovered the definition of a crisis. A crisis is when the center manager is looking at the large memory queue on his phone while he's traveling from one place to another to check on how we're doing. The large mem queue wait times went from 2 days to 4, and that was just too much. So what we were able to do was use XALT, TACC and LMOD data to track who were the big users on the large mem queue, and it turned out to be a particular chemistry code. And they were using the large mem nodes because they didn't understand how to use reduced waitness. So we were able to target those users and get them off of the large mem queue and back onto the regular nodes, just telling them, instead of asking for all 16 nodes, ask for 8 or 4 and double or quadruple the amount of memory that each process has. And so this was something that we could do because we knew what jobs were running, which we wouldn't normally know, and we were able to pair it with TACC stats to say, hey, they don't really need these jobs, you know, because TACC stats will track memory usage, then we can show that they didn't need 1 terabyte. They just needed more than they would get with, you know, full parallelization. So part of this deal was to also provide the data that we're using, but we're doing it in an anonymous way. So help from my student, Sandra Sweat, we produce sanitized data and we report you know, people using VASP and WARF and OpenFOAM and things like that. The asterisk means that's not the name of the program they actually ran, but that fits under that category. And then we change the usernames and charge accounts to be anonymous, and we provide a unique mapping. So, you know, this user is always this user, and their charge account's always that. And then we can map that into field of science, so we can track what field of science you report yourself to, what applications you're doing. And we can find, we've been using some big data analysis tools to find out things that we sort of already know, but we can now prove it. That yes, there's a lot of Python use. Yes, that if you use one, you know, you use NAMD, you also use VASP. So, but this is a preliminary study, but at least we can show the things that we do know, that the data supports that sort of common knowledge. As I said, the way we did this before was we were limited to only track, you know, we could track every link, but we could only track when jobs were run through through a launcher like MPI Run or Ivy Run or whatever your site uses, and we hijacked it. But now we can do an ELF binary trick to actually track all jobs. So I know that Georg is going to talk about some similar trick next, but this is what we're doing. Is there are these functions, well, this thing called the init array and the finite array. You can register a function with the init array, and it'll be called before main, and you can register a function with the finite array, and it'll be called after main finishes, assuming you get that far. And with that, we can compile and link in with your code. So if you use the linker, we throw this extra bit of code in your job, and then we also form this with LD preload. And so we would get it twice, except in the cases where some user sets LD preload to be something other than, you know, LD preload is a colon separated list, but if they just assign it rather than append to it, you know, our tool disappears. So that will capture the stuff that's collected, I mean the stuff that was built with XALT. And we're using both. So that way I have more guarantee of tracking you. Now the downsides of this is, well, I've chosen to only track jobs where the MPI task is 0. That means I'm going to get all scalar things. But if you have a NPMD, that is like you have a climate code that has an ocean model and an atmospheric model, and the ocean model is processor 0, then I'm going to say that, you know, the ocean model had all the processors assigned to both pieces and assign it all to the ocean code, and the atmospheric code won't be reported at all. You can get around that by having every task report, but I don't want to do that. But it's, you know, it's really you know, a site choice. It's the other thing, we used to be able to track the exit status, and I don't know of a way. There may be some magic way to do it through ELF to find out what it is, but I'm just not going to be able to do that. But we can now track all executables, period. Of course, that's the good news is we can track all executables, period. The bad news is we can track all, you know, we're going to get overwhelmed with data. And we can now track what we call the launcher jobs, which are the things that are the embarrassingly parallel, the parameter sweep jobs, because we weren't able to do that before. The big advantage to my mind is I don't have to write and maintain parsers for IB run, MPI run, or whatever your site uses to be a job launcher. And that's a real pain in the neck, because you have to walk over things like IB run, TACC affinity, which assigns, you know, does the numeral control stuff, and then you use a program. that's okay. But if you have things like IB-run and setting an environment variable or unsetting an environment variable and then run your user program, that gets harder and harder to parse because these things it can have a lot of choices here, and while having just the name, walking over the name isn't too bad, walking over its arguments is just a royal pain in the ass. It's just a nightmare, and I'm never going to get it completely right. So, with both LD preload and this XALT NIT linked in, we could possibly get double records, and I don't want to track, at least on Stampede, I don't want to track move and copy, etc. I only want to track executables on the compute node, and I don't want to get overwhelmed by the data. Well, I'm going to get overwhelmed by the data, but I want to do whatever I can to limit that. So the reason why we're using both is I want to be able to track programs that were built before XALT, when I made the new version change. I want to be able to track data on like debuggers and tools like Valgrind and whatever, and if the user overrides LD preload, I want to be able to capture jobs. So I'm avoiding double counting. The thing that I've discovered, at least in my tests, that the init array and the VNE array work like an onion. So the init array is a stack, first in, last out, and the VNE array is a queue, so last in, first out. Oh, I did that wrong, but anyway. Last in, last out. Yes, that's right. And so if you use preload, you'll get, if you use preload and linking it in, it'll be the preload, init array, then the built-in one, then the program, then the built-in array, and the preload. And so I use an environment variable to make sure that only one, to avoid double counting. So I only want to track what it's told to. So if you build an executable on one of our systems where XALT is installed, you can, it checks to see if there's a magic environment variable set. So it won't do anything if it's not. So unless you happen to set XALT executable tracking equals yes, none of the stuff gets turned on. And then I also want to do it so it's only compute nodes, and I'm going to filter based on path. So, and the other thing we discovered that certain programs, certain not bin utils, core utils, CP and cat close standard error before it gets to you. And so I've got a trick to clone the standard error in the init part and then reuse it on the way out. So, because otherwise what would happen is you would see you would print out the fact that init got called, you'd run the program and then nothing would happen, and it did get called, it's just that standard error has been closed so that you don't get any output to it. So I have, and this is we'll have to talk about this in terms of EasyBuild. If you want to have EasyBuild install XALT, the problem with it is that there's site things you have to do. So I have an accept test followed by ignore test. So you can say, I want to match the regular expression, but you probably want to match actual programs. So let's say you want to track the DDT debugger, and maybe it's in user bin, then you'll say, I want to accept that, and maybe bin tar or something, but I'm going to ignore user bin, sbin, and a bunch of other stuff. Now some of it seems pretty standard, but some of it's going to be very site specific and how you lay things out. And so I don't know how you would handle this in EasyBuild. So among the things that are going to be tricky for sites to do is figure out how to test their tools. And so I've written my init tool to be as fast as possible, as minimal tests as I can make it, but a debug version to help with debugging. help with testing. And so you can say LD preload equals this variable, you sign it in the module file, and run your program, and it produces a lot more output. And I'll show you that. Okay. Now comes for the live demo. Keep your fingers crossed. Okay, so type minus A. So I've got the way. Can everybody? Let me try that again. Can everybody see that? The main trick is that LD type minus A lists all the entries in your path. And so it tells me that my copy of LD happens before the system one. And oops. So this defines LD preload. It defines the path, it defines this debug, and turns on XALT tracking. So if you don't, if I unload this thing, then nothing happens. Where it writes to is this directory right here, and I'm going to wipe this out. And then, so if I build something, it produces this JSON file, which has information about the time it was built, what machine it was built on, all the .os, .sos, .as that were linked in with this thing. I'm also capturing the command line, how it was built, and the link program, the path to the program that ran it, the name that was used on the link line, and then some other information where it was built and stuff. Okay. So now let's run it. Let's see. Oops. That's not my path. Let's see if I, oops. Not set. Okay, so now I've got that turned on, and let's rebuild it. New link line is there. Oh, right. Okay. So I'm not tracking because let's find out why it's not working. All right. There it is. So it produces two files, one for the input, one for the beginning of the job, and one at the end. And so it captures the command line that you ran with, it captures the environment that was there, it captures the shared libraries, and captures information that was written to the record. So what I do is when the program gets built, I store inside the executable this UUID, and then I can report it. So then I can tie the executable that was built with when it was run. And so that this build UUID allows me to connect those two. And then there's a run UUID, which is unique every time you run the thing. So those are the main things I wanted to show, that I can track, you know, this is just a regular job, I can track it, I can show, let's see if I can get a little bit better information here. So when, come on, yeah, there it is. I've added a lot of extra statements to track the important variables and say why things are accepted or not accepted, so that it tells you that, you know, yes, the tracking is on, the initial state is null, the rank passes, you know, the host name is accepted, and the path was accepted, and so it, you know, produces this information, and then runs the program, and then the init gets called and tells you, okay, yes, everything's cool, and I'm going to record the record. And so if I run ls, it says, well, yes, I can track, but bin ls is rejected because it's on the ignore list. So I can, you know, I can pick out the executables I don't want to track because it matched the path I told it to ignore. Then it runs it tells me the list of, you know, things, and then it's rejected because the reject was pre-computed, and so it says, hey, I'm exiting. So, you know, so there's actually code getting run, but it's designed to be, and if you take this stuff off, it just works. And then all this stuff gets loaded into a database, and you can do analysis on the database. And so we're able to track what gets used, this data. So TACC stats is also something we importantly use to, it measures performance and start the performance flags, performance counters at the beginning of a job every 10 minutes and then at the end. And it knows that the program was run, and XALT tells it what it knows that a job was run. XALT tells it what programs were run, so we can tie that information together and help track things like what we in-house call the catastrophes, when somebody's allocated 16 nodes to a job and only one core is actually being run, and other things like that. So that's the basic story for XALT. I'll take questions.
What's the jitter of using XALT? So,
Well, it's just the beginning and end. That's it.
Yeah.
Well, and linking.
And you sent it every 10 minutes?
No. Sorry, two different projects. XALT, all it does is what I've shown, namely it produces information about at the very beginning of the job and at the end of the job. TACC stats, which I'm not working on, but my colleagues are. It measures performance counters every 10 minutes. So that's, while, I mean, yes, it does affect the job, it doesn't take very long. And every 10 minutes seems like enough information without being too onerous. Yeah.
So, question in IRC, what about stuff like Python packages and R libraries and XALT is blind to that stuff, right?
XALT is blind. XALT is going to be blind. It's going to be blind to anything that isn't linked in at the time the linker or the job is started. So if you do any sort of dynamic linking, it doesn't know about it. It'll know that Python ran or R ran, but it won't know about the libraries that either of those used. I mean, we've thought about, or we'd like to be able to track that, but each one of those things is going to have its own mechanism to do that. And I don't know how that's going to work when we might be able to instrument the systems version of Python, but not personal copies, for example. I mean, if I have a clue on how this is going to work, we're probably going to have to put some package in there which goes, hooks into import, for example, in Python, and similarly for R. Now, people don't typically run their own version of R, but they do run their own version of Python. Well, I don't know. I'm not an R expert.
Define own version, right? We install our own version of R.
No, what I mean
For the users.
But yes.
So if XALT would need a patch in R or a patch in Python to like hook out to XALT or to provide XALT a hook that can actually know what's going on. It's going to be language specific, of course.
It's going to be language specific. No, what I mean is that while it's common for, or certainly not impossible, for users to build their own copy of Python. So if we patch the system one, we won't catch the personal one.
But it's the same thing for everything else.
Yes.
But you know their Python paths, so you have an idea what they could load.
Yes, well, I can report what Python path is. Can I? Well,
That's it. It's typically in the environment. But there may be other stuff.
yeah, but I'll have to do some magic to say that copy Python because all this stuff is done internally to Python, and I've unset Python path. I'm going to have to rename it and say, do this switch to say, oh, the user's Python was equal to Python path, and then pass it through and all that.
So does that mean that if you now have Python path in the environment, XALT will not catch it now because you unset it?
I'll have to do it right now. Yes, I'll have to do some magic to.
Renaming or
Yeah.
But I've looked into this. It is probably possible, but it's kind of invasive.
you have to patch Python. Right?
Now, well, if you're preloading, you could hook the function that's in there, and there is a function, and you get the imports out because if that actually you see what gets imported.
Yeah.
But that is pretty invasive.
Yeah.
So anyway,
How do the users feel about being tracked, or is it just part of the deal?
well, you're on
Helping the users.
I mean, that, you know, they don't really know. I mean, we don't, it's not that we to hide it from them, but we don't go out of our way to tell them. But they know that there's tracking going on of some kind. I mean, it's like Google. But one of the issues that I'm having to deal with is, in the United States, we have these things called HIPAA and FERPA, and there's probably another one for other kinds of data. So HIPAA is the regulations that control patient data, and FERPA is the thing that controls student data. And you have to be careful about doing that. And so one of the things that I'm concerned about is that XALT, by its nature, is capturing the command line in the environment, and that can have patient information in it if it's got HIPAA data in it. And so one of the things we're going to do is that we're going to make sure that if your HIPAA, XALT's not on, that we just don't track that kind of data, because I don't want to have to manage. I mean, I don't want to have to manage that kind of data. But I want to be able to, you know, for most people, I want to be able to track the command line and how the thing was linked, because there's information there that we can help figure out, hey, you know, this program's getting used a lot and it was linked poorly. But one of the problems with XALT and TACC stats and a lot of this stuff, and even the stuff they do here, is there's way too much actionable tasks than we have manpower to deal with. But it's there.
Yeah, that was going to be my next question. Have you taken a lot of action based on this?
Well, we have. We use it every day. I mean, because it goes through the TACC stats. It helps us with this this thing, the tracking the chemistry code and putting things in the wrong behavior. You know, getting library usage. All that stuff we use to help manage our system and find out what's being used and what's not. And we're still figuring out more things to do with it.
And you see it better than just counting what modules people actually have loaded, because you actually see exactly what they're...
Well, you know, we still, I mean, if I have PETC loaded, I may not be linking against it, but at least now I know they're actually using it. And I also know I can get an estimate of how many, you know, for a library, how much it gets used. You know, is it, you know, does it occupy a lot of time on the system or not? Now, it's not a perfect because it's not performance data. I won't know. You could build a program that links with FFTW or PETC or whatever, and never use it, and I'll never know. But it's still, you know, useful, I think. Okay. Yeah.
Do you have an interface to access the data? I heard you had some project.
There's a project, my colleagues at NICS have a web interface to this stuff that's still, you know, not quite ready for prime time, but we're working on that. And I'm working on scripts to better analyze the data. And I'm also working on trying to deal with the fact this data is big. I mean, big compared, well, it's not really big. We're talking gigabytes, not terabytes. But that's big for me. And doing this on a VM, I'm having to work on speeding the database up. And I'm learning way more about databases than I really should have to, but just to get enough speed. And the other thing I've worked on is improving the speed of the module, the database I use to track the module usage, to get it, you know, to get better performance out of inserting and better performance out of, you know, actually searching the data. I've learned about partitions. I'm going to learn about views and all this stuff. So, anyway, anything else? Thank you.
Thank you.
I have one more kind of question. Like, so as regards a community or whatever, some partition of the scientific space,